Okay, so we are going to be focusing on the outcome PC 20.4, expand and demonstrate understanding of primary trig ratios and determine exact values. In order to do this, we're going to need to go and examine some different characteristics of angles. We're going to be using Chapter 2, Trigonometry, from your PC 11 textbook. This will be our primary resource. So what you see here is right from your notes. So 2.1 angles in standard position is where we're going to start. An angle in standard position has its vertex at the origin, 0, 0. So that would be that point right there. And its initial arm along the x-axis. Okay, so its initial arm is always just right along that x-axis. Forgive me for not doing that perfect, but that's where the initial arm of every angle in standard position is. When the angle of rotation is counterclockwise, then we have a positive angle. So this angle here is going counterclockwise, or the opposite direction that a clock goes. And so that would be a positive angle. If we had an angle going the other way, say this way, that would be clockwise, so that would be a negative angle. So to the right here is our Cartesian coordinate plane, or sometimes just called our Cartesian plane. You should become familiar with the Roman numeral labeling of each of the 4 quadrants, as well as the measure of the angle in each quadrant. What we're talking about by Roman numeral is that's a 1, this quadrant is quadrant 2, this quadrant is quadrant 3, and this is quadrant 4, or 1 before 5 is how it's written. In quadrant 1 you have angles from 0 to 90 degrees. This straight up and down here would be a 90-degree angle. In quadrant 2 you would have 90 to 180 degrees. Quadrant 3 would be 180 degrees to 270, and quadrant 4 would be 270 to 360. So become familiar with each of those, and what we mean by that is if I were to say a 70-degree angle, you should know that's in quadrant 1. If I was to say a 200-degree angle, you should know that's in quadrant 3, etc., etc. This little sign, so this is theta, which we use as a symbol for angle, and then it has a subscript r, is called a reference angle. It is the measure from the terminal side of the angle to the nearest x-axis. It is always a positive acute angle. And let's remember that acute means that the angle is less than 90 degrees. Okay, that's what acute means. So that's an important thing to remember. All of your reference angles are going to be smaller than 90 degrees. So if we look at this example here, well, here's our angle in standard form. Okay, it starts at the x-axis, it goes all the way over here, and its terminal arm is right here in quadrant 3. Well, if we were talking about a reference angle, we would be talking about how far is it from the closest x-axis. Don't worry about y when you're doing a reference angle. It's how far is it from that line. And so right here is that distance. Okay, and no matter what way you look at it, we're always going to measure it as a positive angle. Okay, and it's always going to be acute. It's always going to be less than 90 degrees. So if we take a look at some examples here. Now this is important to me. We're asked to sketch. When I use the word sketch, usually what I mean by that is it doesn't have to be perfect. Okay, so A is asking for us to sketch a 24-degree angle. Now 24 degrees, well, that's between 0 and 90 degrees, so I know that that's going to be in quadrant 1. And what we could do is we could go all the way around here and look. Okay, B is 104 degrees. That's between 90 and 180, so that's going to be in quadrant 2. 204 degrees, well, that's between 180 and 270, so that one's going to be in quadrant 3. 304 degrees, Well, that one is between our 270 and our 360, so it's going to be in quadrant 4. 24 degrees, well, our initial arm is always this, right on that x-axis. Okay, so what we want to do is we want to go 24 degrees. Now I know that the whole angle from there to there is 90 degrees. Whoops. Is 90 degrees, and I don't want that. So half of 90, which would be about right here, would be 45 degrees, and I know I'm about half of that. So I am going to draw roughly a 24 degree angle. And then I always want to show that I'm going from the x-axis and I'm going to that angle. So I draw a little kind of an arc with an arrow that's pointing to that. So that would be 24 degrees. Okay, if I move over to B, I've got 140 degree angles. Well, I always am starting here. I know that straight up, that Y would be 90 degrees, so I need to go just a little bit further. Okay, so 104, if I have 90 and I need to get to 104, that's about 14 degrees. So it's even smaller than the angle that we drew in A. So I'm going to kind of draw straight up here. And I'm going to show that this is my angle. Okay, and that angle is 104 degrees. C, we said, was in quadrant 3, and it's 204 degrees. So again, I'm starting here. If I went to the y-axis straight up and down, that would be 90. If I went over to the other side of the x-axis, in other words, I made it into a straight horizontal line, that would be 204 degrees. Or sorry, that would be 180 degrees. So I need another 24 degrees from there to get me 204 degrees. Again, all of these angles are positive, so they are all moving counterclockwise. And then finally, D is 304 degrees. Well, I'm starting here. This line would be 90, this line would be 180, this line would be 270, and this line would be 360. So if I'm 270, I need to go another 30 degrees to get to, well, another 34 degrees to get to 304. Okay, I should think, okay, from here to here, that should be about 34 degrees. This one is much bigger. Okay, it's about 56 degrees. So it should be almost twice as big, right? And in my sketch it is. It doesn't have to be perfect, but it's nice when you can tell that the one side is bigger than the other. So there's my 304 degree angle. All of those are in standard position because they start at they have their initial arm on the x-axis there, and then we rotate around to the terminal arm. For our next group of examples, it says, what is the reference angle for each angle in standard position? Again, it's going to be really important to note, okay, that 55 degree angle is in quadrant 1. 155 is between 90 and 180, so it's in quadrant 2. 255 is between 180 and 270, so it's in quadrant 3, and 355 is just shy of being a full circle. It is in quadrant 4. And we want to know the reference angle. So when I kind of think about a 55 degree angle, okay, it is somewhere in here. The closest x-axis is actually the one that we started from. Okay, so when our angle is less than 90 degrees, then our reference angle, which again we make that little theta with a little r subscript, is actually exactly the same. Okay, if I go to B, 155 degrees. Well, I know to go to straight up and down this y-axis, that would be 90 degrees. I know over here would be 180 degrees. So 180, I'm going to go back to 155. So that's about my, just make that a little nicer, that's about my 155 degree angle right there. Right? And this is standard position, 155 degrees. I don't want standard position though, I want my reference angle. And so to get from my terminal arm to the closest x-axis, I actually just have this little chunk. Well, how the heck do I know what that is? Well, if I know to get from here to here is 180 degrees, well, I can take my 180 degrees and I can subtract that 155 degrees to give myself a reference angle. And in this case, our reference angle is going to be 25 degrees. It's just this little angle that I've labeled blue. Now, the terminal arm's in the same spot, but it's a nice small number to work with, and that's going to come in handy later. Okay, again, if I have Cartesian plane, 255 degrees, that's going to be in quadrant 3, and it's going to be really, really close to this bottom y-axis because it is almost 270 degrees. Okay, so here is my standard position angle. Again, I'm not thinking about my y-axis. I'm only thinking about the closest x-axis when I'm thinking about my reference angle. So my reference angle is actually going to be this angle here. So from the closest x-axis to my terminal arm. And again, it's hard to tell exactly what that is by guessing. So what could I do? Well, I know from here to here is 180, and then I've gone more, 255. So to find out the difference of that, I'm going to take my 255 and I'm going to minus that 180 degrees. And it is going to give me my reference angle. And if I take 255 and I subtract 180, I'm going to get a reference angle of 75 degrees. So that's that green angle. Again, this is going to be really important even in the next part of this section. Okay, 355, well, that's going to take me almost all the way around, really close to being one full circle, 360 degrees, so probably even closer than that. And my reference angle is to the nearest, how far is it from my terminal arm to the nearest x-axis? So it's actually this little angle here. So I'm going to use some knowledge. I know that one full circle is 360. And I'm going to subtract that 355. And I'm going to find out that my reference angle is a little tiny 5 degrees. Okay, so notice all of our reference angles are just the difference between our standard position angle and the nearest x-axis.